So we've looked at graphing systems of equations. Now it's time to graph systems of inequalities. So let's take a look at this first example. Y is greater than 2x plus 1. And we have another equation, y is less than 2x minus 2. If you recall from last chapter, graphing inequalities, we're going to want to graph these two boundary lines of these inequalities. So in this case, I'll bring up my graph here. Let's label these equations with colors. We'll call this first equation, we'll label red, and we'll call this second equation 2. We're going to label it in blue. So first, let's graph our first equation. The boundary line is going to be at y equals 2x plus 1. So we're going to have a y-intercept at 1. And we're going to have a slope of positive 2. So we're going to go up 2 and over 1. And then we'll go up another 2 and over 1. And we'll put a line through those 3 points. Alright, so for our blue equation, we have y is less than 2x minus 2. So this time we have a y-intercept at negative 2. We have a slope still of positive 2, so we're going to go up 2 over 1, up 2 over 1. And we'll put our line in. And based on the slopes of those two lines, you should have been able to reason that those are going to be parallel lines. And one last thing, since these are not inclusive of the lines, they're only less than and greater than, we're going to make these lines dashed. If they were less than and equal to or greater than or equal to, they would be solid lines, but in this case they are not, so we're going to dash them. So since y is greater than 2x plus 1, my red equation, we're going to shade above that line. So let's shade all this region above that line. And since for our blue equation, y is less than that blue line, we're going to shade below the blue line. So notice that there is no place that this red line overlaps the shading, or there's no place where this red shading overlaps the blue shading. So in this case, there is no solution. We're going to call that null. So there is no solution in this case because none of our shadings overlap. Right, so let's say we have these three equations. We have y is less than or equal to 3. We have y is greater than x. And we have x is greater than or equal to negative 2. So we will label this one red, this one will be blue, and this one will be green. So y is less than or equal to 3. It's going to be a solid line because it's less than or equal to. So 3, meaning it has a y-intercept of 3, we can assume a slope of 0 since there's no x included. It's basically the same thing as y is less than or equal to 0x plus 3. So we have a y-intercept at 3 and a slope of 0. So we're going to go up 0 over 1, up 0 over 1. And we'll have a horizontal line going across there. So then our second equation, we have y is greater than x. It's going to be a dashed line because it does not include the equal to. We could also think of this one as y is greater than 1x plus 0. So therefore we'd have a y-intercept at 0. We're going to go up 1 over 1. We'll go up 1 over 1. So then we put our line connecting those 3 points. And finally, for our green equation, actually is does not include a y variable, but we can see that x is always going to be equal to -2. So that's going to give us a vertical line. So let's go ahead and plot our points. X is always equal to -2, so we'll just plot some points on x equals -2 and put our line there. Alright, so, and again, let's not forget to make this blue line dash since it's just greater than, not greater than or equal to. Now we need to decide which parts of these we should shade. Alright, so for the red line, we're shading below, the y values below that red line. So we would shade kind of this area below that red line. This is going to cooperate with me. Alright, so then for the blue line, we're going to shade y's above that blue line. So if you can see the blue line still below all my paint here, we're going to shade above that blue line. Notice how it overlaps the red at certain parts. Finally, for our green line, we're going to shade values that are greater than x, since it's so we're going to shade to the right. So we're looking at those values that are greater than x. Notice that all 3 shadings cross this particular region in the middle, right about here. This yellow region is where all 3 shadings of each line meet. That yellow region, obviously your graph isn't going to be as messy, but that yellow region represents the solution to those 3 inequalities. Alright, so now we're going to look at graphing this inequality. The absolute value of y is less than or equal to 4. So let's take a look at graphing. What would our boundary line, the absolute value of y equals 4, look like? Well, remember that y, where the absolute value represents the distance from 0. So if I were to graph the absolute value of y equals 4, we're talking about a distance of 0 that is equal to 4. So y could either be 4, that would work for this equation to be true, or y could equal negative 4. So I'm going to end up with two horizontal lines. Since I have no x, there's no slope. So I'm going to have a line at y equals 4, and I'm going to have a line at y equals negative 4. Both are solid because I have greater than or less than or equal to. Since I have that equal to, I make two solid lines. Notice that it's less than or equal to. So the part that I'm going to shade, sorry about that, I lost my line there. The part that I am going to shade is going to be close. It wants to be close to 0. Since my distance from 0 is going to be less than 4, I don't want to go beyond 4 on either side of these absolute value lines. So I'm going to graph in between them. Since I want my distance to be less than 4 away from 0, less than 4 away from that line y equals 0, I'm going to shade in between. Remember, less than, I want that distance to be less than. That means I want to be close inside these bars. On the other hand, if I have something like the absolute value of x is greater than 3, that means I want to be further away from 0. I want my distance from 0 to be further away than 3. So let's look at our two possibilities and then graph them. X could either be positive 3 or x could be negative 3. Both of those are going to yield me 3 if I put them in absolute value bars. So let's go ahead and put two lines on x equals 3 and x equals negative 3. And remember, since it's not greater than or equal to, I'm going to make those lines dashed. So let's go ahead and do that. And finally, since my distance, I want x to be greater than 3. I want my distance from 0 to be greater than 3. That means I want to be really far on my graphs away from the origin. I want to be more than 3. Anything closer than 3 is bad. And so I'm going to go ahead and shade the outsides of my graph. Notice that those shadings never intersect, so therefore the solution ends up being on the outside of the two. That concludes our lesson on graphing systems of inequalities.